Good morning, friends. This is GV Shivakkumar, and today I like to discuss about SAP Business Technology Platform, which is based out of Sub Analytics Cloud, right? Actually, HANA is for HANA Sub Analytics Cloud. It is simply called SAC. And this BTP is very new technology for each and for everyone, right? Actually, so this is a not. Actually, this is not used in general, right? So back to our case, actually. Okay. Once again, I'm sharing my thanks and hearty welcome to each and everybody. And this BTP is very new technology in SAP S4 HANA. So design SAP Logistic Cockpit and everything, right? So you can create a logistic cockpit track starting from vendor procurement for a raw material, then actually going with receiving the stock material, and then sending to quality inspection for the incoming raw material. Once that is done, then you are doing put away and placing the stock in raw material warehouse, and then issuing back the raw material against a production order release. Once the production order is released, it will be issued to the shop floor. Once the raw material is converted to the finished goods, then actually again one more quality inspection check for the finished products. So if everything good, actually you will place in finished goods warehouse, right? And in some cases, actually before placing to the warehouse, in rare cases, actually you can once a quality inspection release is predetermined, you can prepare for the trucks for the transportation. Either all your deliveries can be clubbed to a single truck or a transport system, or it can be splitted based on your customer requirement, or different customer is involved. Actually, you need to have a different truck arrangement. It again, it depends on the business requirement, right? You cannot determine on this is a standard process. I need to bring everyone in the standard procurement process. That is not at all possible. Okay. So important thing here, actually. So once that truck is everything is loaded, pick, pack, and loaded, then actually it will go through the sequence of route. Say for example, if you are planning to supply the goods from London, so it will go to France, that is Paris, or it will go to Germany, Hamburg, and then it will go to Berlin, or it will go to then actually it is go to say I can say Belgium, and then actually it will go to Switzerland, and then actually Norway, Sweden, to end point of Europe, right? Turkey. So we have when traveling from end to end point, say London, from London to west to east Turkey, right? The end of the Europe. So you can see, I can say actually a lot of countries or in between the travel path, right? So you need to get in touch with each border area. So actually you cannot in some cases, very rare cases, in some European countries or some places, actually you cannot travel with the same truck at that point of time. End of the Germany, actually you need to unload that goods in the Germany border, and again load it in I can say uh, the next country border starting, right? Say Belgium or Switzerland, whatever it may be. So just I'm giving an example. It is not exactly the same what I am telling. So what I'm doing is this. If you have a end-to-end monitoring thing, so if there is any delay, or the stock, if stock is available at the border of the country, one country, so the starting of the border of the next country will, they can do the on the spot carrier booking. They can immediately pick the goods and the load to the transporter or a truck, and then again they will start their next series of travel, right? Say for example, Germany will have a one distribution, whereas London is having main manufacturing warehouse. From there, actually, you are transporting to Germany. So you are partly unloading stocks, and they are doing put away in the distribution warehouse in Germany. And part of the 50 percentage will be taken to say for example Switzerland. Switzerland, you can say some 10 percentage will be put away to the Switzerland warehouse, and remaining 40 percentage will be taken to Belgium. and you can do some 10 percentage put away in a Belgium warehouse, and then 10 percentage in Sweden, 10 percentage in Norway, and finally when you are going to Turkey, some you are doing the remaining 10 percentage distribution in their country with respect to the customer orders in Turkey. The Turkey customers, whenever placing the request to the customer order request to the London plant, main manufacturing thing, so they can distribute among the regional distribution center, and from where the, say for Germany you have loaded some 50 percentage of stock when you did put away, right? So from Germany distribution warehouse you can distribute to the local customers in and around Germany. And then if you are considering for Switzerland, you can distribute the nearing customers in Switzerland main distribution warehouse, like that till Turkey you can do that. So if SAP BTP will have the facility to create a front end cockpit, thereby integrating your SAP ECC, SAP system, or SAP S4 HANA system, or R3 4.7, or Ariba, SRM, or ZRM, APO, and then actually EWM, WM, MM, LETRA, event management, so SD, OTC, GIS, GTS, everything. So all the modules, right? Whatever modules, SAP TM 9.6, whatever, all these things, right? S4 HANA or ECC, all the systems can be clubbed through a cloud environment or layout, and thereby integrating through a, if you are having B4W HANA for integrating data warehouse, I can ingress layer normally in architectural level speaking, and therefore actually you can partly you can connect all this data to the logistic cockpit, and logistic cockpit will have a data pool or a internal data master inside that, and there actually you can process through SAC, and then you have IoT, Internet of Things, artificial intelligence, and then artificial intelligence, robotic process automation, RPA simply called, and then we have embedded analytics in SAP. SAP S4 HANA is there. Then we have OLTAP, OLTP, OLTA, all this online analytical processing, online transactional processing, everything is there. You are utilizing all these things, and then actually you are performing all the integration starting from I can say vendor procurement raw material from the vendor to the end customer delivery. So integrating all the ERP operations, that is SD, PP, WM, QM, EWM, TM, APO, or whatever, GATP, GIS, GTS, everything. So all this shipment, transportation, so all this actually SRM, Ariba, all these things, whatever SCM models, all the models can be integrated and can interact with the centralized cockpit, from where the user can monitor, control all these activities of logistic activities, starting from procurement till the end customer delivery, right? All this can be tracked and tracked and traced from end to end point. Okay, so next, actually this is the overview of the main aim of this video, to explain how the BTP will help the end-to-end tracking and tracing of end-to-end movement of the material with alignment of Subanalytics Cloud in SAP S4 HANA, right? So this is really a good innovative idea. Nowadays, actually, most of the pharma or a drug company or a life science company or healthcare company or a beverage company can utilize that. So let's move on to the next phases of the slide. So BTP logistic cockpit design. So it will, it will help you to, I can say, from starting from business technology platform, you employ deploying the Subanalytics cloud. So Subanalytics cloud will have I can say all your analytical part of I mean processing, right? Analytical, I mean in addition to the SAP, I can say SAP oriented inbuilt or embedded analytics. Actually, in addition to that, we have I can say additional cloud processes, right? So next, actually, you are seeing the functional and logical view of the end, I mean current pharma or biotechnology value chains, right? So here actually you can see the I can say the supplier who is supplying the material based on the purchase order sent by the main purchase department in the drug manufacturing company. So once the order is received, they will distribute the stock with a delivery challan to the main company. And once they receive the product, they will verify the delivery challan with the exact stock they supplied. And then actually they will do a quality inspection check. Whatever QA 11, QA 12 or QA 32, all this operation happen and they are doing put away here. And once the put away happens, actually they will I can say so they can do put away using once the quality inspection has been released. So those who passed in quality inspection will be put away in the main warehouse, and based on the manufacturing requirement, based on the process order. In case of pharma or biotechnology, it is definitely a process manufacturing. So process order is created. Based on the process order release, actually they will issue the raw material warehouse to the shop floor. And once upon series of movement between work centers, the complete routing operation and all the raw materials can be converted to your finished goods. And then you can either set up automatic replenishment or manual replenishment, and then actually an outbound delivery will be created, and then again actually followed by the TO creation and confirmation. So you are moving the raw material to the finished goods warehouse after one more finished goods quality inspection has been made, right? So everything done, actually the material will be placed in the finished goods warehouse. And so once a quality inspection date is predetermined, you can you can do packing, picking, packing, labeling, everything, right? So once the goods receipt has been done, actually parallelly the label generation happens. Once a TO is confirmed, label generation happens, and then actually it will be shipped to the transporter, either based on the one single delivery or one single customer, or a multiple customers required, multiple truck is required. Say for example, if particular delivery involves multiple deliveries or multiple truck into a requirement is there, or the date of quality release is different for different materials, then in that case you need a multiple truck, and which can be transported once the quality finished goods is released. So it will be taken from warehouse till actually it will be loaded to the truck. Again actually it will be taken to the primary distribution centers. For example, I have explained here Germany, and here for example the main warehouse in UK. Okay, and this say it is a UK, and this is Germany. Okay, and you can do for some 50 percentage of or 25 percentage of put away in this location, and thereby you are supplying to the local customer here, and remaining material will be taken to say some location, say Belgium, and remaining material will be transported to Switzerland, Sweden, Norway, till the Turkey, right? So based on that, actually the final customer either actually from they even within the Germany they have primary distribution warehouse, and then secondary distribution warehouse. Secondary distribution warehouse will deal with the wholesalers and distributors, and then actually from the wholesaler or distributor, retail distributor or wholesale distributor, it will be supplied to the end customer. So what are the things here you if you are looking, say here actually between the drug manufacturing and warehouse, we have intra logistic transport, and actually from the main UK warehouse to the manufacturing warehouse to the France or Germany, we have a mode of different logistic mode of transport: rail, air, ocean, road, whatever it may be. Okay, and then again actually from the primary distribution warehouse to secondary distribution. If it is a long distance, then actually it should be ocean or air or or rail. If it is shortest, it must be road, through some road. So it depends on the distance between the warehouse from country to country. And all this, I mean, say for example, some heavy material can be transported through either cargo, that is a sea cargo, and through rail or road, right? And say minimum medium level materials can be transported to the road, right? And then actually if it is some minimum, I mean, kind of, actually I can say very less weighted material. In that case, actually you can say you can transport through the I can say air freight. So you cannot load more than more heavy material in the air cargo, right? So that is important. Say, and then actually drug can be loaded, because life-saving drugs like cancer or I mean tablet for corona kind of thing actually can be transported through definitely through a I can say to the air, right? Immediately it should reach and need to save the many end customer or many public life. So the air transport is required. So again, actually it depends on the country to I mean the type of business, country to country, depends on the scale of the industry, I mean customer industry, everything matters. They need to pay, right? So all this transport charge will be loaded to the material cost, right? And one fine day they need to pay the entire cost for the material. And then it applicates till that, I mean, when again the once wholesaler receives the material, then again they need to send through either road or rail or air or ocean, right, to the end customer, the same distributor also there. So here what are the actions, I mean, key supply chains, right? Knowledge processing, I mean, what are the merits you are attaining, right? So using BTP, deploying over the logistic chain, starting from raw material procurement vendor to end customer delivery, right, of finished goods. So we need to have an end-to-end process of monitoring and lead time optimization, right, using BTP. And in addition to the subaltern cloud SAC deployed. So what are the factors improved in logistics chain means, in case of from vendor to put away, I mean put away receiving the raw material, we are increasing the source lead time, and then issuing the raw material to production and getting back the finished goods and placed in the warehouse. That there actually you can improve the manufacturing lead time. And actually I already told, actually we are doing the finished goods raw material inspection, right? So there actually you are doing quality inspection lead time. And then for internal warehouse operation, pick, pack, load time, right? So all these warehouse monitoring load times can be lead times can be improved. And again, actually when transporting between the primary secondary thing, right, we have a location coordinators are there you need to maintain the temperature log and external environmental temperatures disasters if any, then you need to take an alternative path to reach Germany, right? So actually what are the possible things here? I mean, you need to use actually either GIS, geographical information system, geographical positioning system, everything is required. Geographical information system will tell you whether any rain or heavy temperature is there, because you are carrying a pharma or a drug, I mean medicines, right? Actually that requires some temperature maintenance and all these things to be keep in a very cooled environment, right? So if more temperature then actually is there, actually then chemical composition will undergo change, and the total medicinal effect will undergo change. So you cannot use it for further, I mean you cannot use for the further processing in say for example the Germany customer orders some raw material for their manufacturing of drugs. So if you are carrying in high temperature, then the chemical composition happens. Once a chemical is heated, there is some state change, right? So cooling will give something, and more temperature also give some state change. So we think we know, so GIS, geographical information system, will give you whether any natural calamities or more heat is there or any heavy rain is there, something happened, then it will tell you predetermined. So user can take alternative. I mean, they can, this main warehouse people take will arrange a I mean a different route to transport the material to Germany. And GPS say for example due to political or natural calamities happens. So if any thing happen, actually they can divert, either divert from road transport to rail transport or rail transport to sea cargo. So they can change the mode of transport based on, so that actually the end customer will receive the immediate stock, right? That is very important. And so here the temperature logs and I can say all the events can be tracked. So land transportation lead time get increased. Okay, this is very important. And again, actually, in between transportation from the primary to secondary, right? Here also we need to have temperature log, and all the events can be transported and tracked. So outbound lead times can be optimized. And say again, each and between each and every transportation and distribution and put away, we have the land transportation is optimized, right, till the end customer delivery. So all this combining source lead time, manufacturing, quality control lead time, picking, packing, lead I mean loading, all these things, right? Actually the warehouse lead times and lane transportation planning lead times, all this can be outbound lead times, everything combinedly jointly called as we can say end-to-end lead time, right? This will help the one manufacturing company to optimize I can say or I mean optimize their benefits, as well as they can able to on the spot they can say it can support on the spot booking, and immediate transportation to the next country is possible. So these are the main advantages. So this is the overview of functional or logical overview of logistics for the pharma or biotechnology or a drug or a whatever I say beverage industry, the same case applying. So next we are moving to the next screen. Okay. So here we are seeing what are the current I can say here I can say what are the possible changes, right? In case of current day-to-day business, what are the functional challenges and technical challenges, right? So whatever you are seeing, right? Say in case of customizing, some informations are based on customized settings. Example, P2P, procure to pay, goods receipt processing times, warehouse pick and pack lead times, and then transportation lead times based on routes, ATP check, and then in case of master data, supply chain lead times are also based on master data settings. Procure to pay lead times, that is material master info record, material masters can be properly monitored and tracked, right? What those changes I'm telling. And manufacturing lead times, that I mean especially for the material master, and transportation lead times based on the routes, transportation zone in business partners, and then transportation route after delivery creation cannot be changed in OTC after the delivery is flowing to the SAP EWM. So these are the transactional challenges and functional challenges, right? And transportation route cannot be changed in the deliveries after shipment planning. So I think I don't want to discuss all these things in detail because everything is clearly documented here. So different legal requirements, example, Italy after the shipment planning, the shipped cost need to get released so that during the goods receipt, the acquisition cost will flow into the material price. So these are the transactional challenges currently we are having, business is having in the pharma industry and everything. And so this customizing and master data will help you to design your data should not be changed throughout the logistic cockpit, and this correct time of changing transaction data needs to be processed for transactional data, and in case of different modules integration, right? So different module within the different system, example SAP EWM TM and LETRA WM in case of ECC, and this EWM TM in case of S4 HANA. So EWM and S4 HANA will have a, say I can say embedded systems on the S4 HANA, right? So integration of different layers, example, one for tempo, one for I can say one for ECC and one for I can say S4 HANA needs to be finally discussed, right, before taking care of. So we can here I can say one important thing is actually we can club ECC and S4 HANA or even R3 4.7 versions. We don't want to migrate all the systems. So using the hybrid technology in S4 HANA functionality, we can club all the on-premise or cloud systems and also different versions of SAP and non-SAP systems. Say, for example, if your organization will have a order management tool which is a legacy system, or a planning tool which is a JDS system, or any some other JD Edwards, or whatever system, say Oracle or whatever it may be, say even for I can say even for tally kind of thing for accounting can be interacted with SAP BTP. This we can do very efficiently, right? So this is the advantage of BTP to get integrated with all the different modules. So here next we are seeing the background and requirement of logistic cockpits, so, right? So we need to consider, before considering any system, we need to consider important thing, two things, or strategic level at the corporate level and operation level at the manufacturing or business user level. So for that only we need to have a logistic cockpit and should have analytical and predictive diagnostics involved in that. So if both having integrated, then your approach will be more efficient. You can easily track from starting from vendor procurement, I already told, till the end customer delivery, right? So this logistic cockpit will have end-to-end value stream to be predetermined, and then also end-to-end value stream lead times to be, whatever supply lead times or procurement lead times, or a manufacturing and quality control lead times, picking, packing, and put away, or issue and labeling. All this comprises of a warehouse lead times. Again, say for example, actually distribution or order management or transportation will cover the LE part and SD part, sales and distribution part, right? So all this transport analytics or lead times can be improved, right? So these two comprises of logistic cockpit design, which suppose end-to-end value stream and end-to-end value stream lead times. These are called these are the KPI lead times to be considered in case of logistic cockpit design. When coming to predictive logistics, we need to have optimum supply trade-off. So actually, in the sense, actually we have a efficient on-the-spot booking and immediate transport of goods from one point to one point, right? Point to point, we need to have a correct balance of transport, material transport is there, and then we have predictive logistic algorithm to be maintained using the SAC Sub Analytics Cloud and inbuilt or embedded analytics in S4 HANA. So here actually I just showed the different systems, say JDA or order management tool with legacy systems, non-SAP system, and ECC here, and then we have S4 HANA, TM, EWM. All these things can be clubbed and can be integrated with the logistic system, which is having analytical and predictive logistic involved in that, which optimize finally the end-to-end value stream and end-to-end stream optimization or increase in lead times optimization, right? So that is important, and which is having optimal supply trade-off and predictive logistic algorithm, right? So these are the thing actually we can deploy using BTP, using I can say IoT, artificial intelligence, and then artificial intelligent robotic process automation. All these things will give the predictive logistics and analytical tool. Okay, I hope actually you can understand in the coming slides. So next thing, actually here you can see the significant considerations for architecture design, right? So if you're considering for logistic cockpit, designing a logistic cockpit, what are the consideration to be done? So system of record and integration topologies offered. So which where SAP giving what are the integration system records or topologies is used, and significant event modeling across the values chain, right? Actually, for that we need to have a event management system which can control O2C, P2P, and then PL2P, and then LETRA or WM, all these things actually plan to load everything, right? So plan to stock everything. So all this supply chain metrics can be optimized. And data process, data process which is showing the freshness, right? Fresh data to be displayed in the cockpit. That is very important. It should not be a old data. So it should be refreshed in each and every time within a micro or macro seconds, right? And the data should be correctness in all the state. So that is a correctness requirement expected by the business, where actually or they are expecting from SAP using BTP and SAC, which is an advantage over other ERP systems or other logistic cockpit you are developing with Oracle or any system. So these SAP facilities will make SAP the number one in the ERP field, as already told. And monitoring and lead time models should be optimally advised. This comprises the considerations for the architecture design. Next, I already told actually what are the significant, I can say the functional or logistic requirement or drawbacks currently facing in the logistic field, right? They need a logistic cockpit, analytical and predictive diagnosis is required. So they need to maintain end-to-end value stream mapping in for logistics, and logistic hub design which clubs all the data models, application interfaces and integration, so-called APIs, right? And logistic cockpit channel requirements and ecosystem dependent data services and process and readiness, and if any gaps identified can be leveraged with the existing BTP or in addition to the SAC. So it comprises of a foundational platform for achieving all the logistic requirement and can optimize the lead times. Okay, that is important. And what predictive logistics will say, right? The predictive models and associated data requirements can be tracked and traced as much as possible, which lead to the optimized lead time. And second, extent of historical data requirements for the prediction. And third one, so historical data always to be maintained, because for that only BTP law, architecture will provide an internal storage, which is a HANA data storage, right? So actually it's a kind of cache kind of memory. You can store the data till that next data will be coming, or the user wants to clear that memory stack. So till that time it will be there, it will be supplied to the OLTP and OLTA processing, right? So all this the trending and storing of data is much more better than the other ERP, ECC, or sorry, other ERP system. So SAP has achieved that. So that is the extent of historical data. Data can be stored and retrieved at any point of time. So proper data security is mentioned without deletion of data. And second thing, the post prediction closed loop is achieved. So the once the output is reached, those output data, trending data, can be given as an input, so it can act as a feedback controller. So whatever the uncertain or unpredicted issues happen, the output will give an experienced input to the experience input taken as an input. So actually again that correctness will be at the actual, and the estimated results can be based on the prehistoric data can be leveraged, and you can get a you can avoid the future mistakes, right? So that is important. That can be done through a closed loop in case of BTP and SAC combination in SAP S/4HANA. So the post prediction of closed loop integrations for any action, any logistic action. Okay, and then domain specification prediction services with shared services. Okay, whatever domain issues will come, so SAP can able to track and trace that and able to put a stop on the error results and make a positive result to the end-to-end logistics. So these are the predictive logistics and analytical actions required for the BTP with in addition to SAC. Okay, for the for designing end-to-end logistic cockpit. Okay. So next here actually the diagram I have created here actually, say for example any ECC system or S4 HANA system or third party order management tool or a transportation management tool or a warehouse management tool, say Manhattan warehouse, whatever it may be, right? All this say, and then actually laboratory information management system, LIMS, manufacturing execution like Rochester, Siemens, whatever it may be, any system can be integrated with the logistic cockpit here. So say this is a overview of a logistic cockpit. We will have SAC as a core mind or central processing unit with analytical capability, and it is integrated with the master data in interface, and then intelligent RBA, and then Internet of Things, artificial intelligence, internal master data pool is there, which is managed by the master data governance. So then actually we are connecting with the existing on-premise or server-based technology with the cloud using either DWC, that is the data warehouse cloud, or through BW4 HANA. If your organization already have BW4 HANA for integrating as a ingress layer between ECC, I mean with the SAP ECC or S4 HANA with the logistic cockpit, you can use B4 HANA. Or otherwise, if you are not having any interface with the cloud, on-premise integration with the cloud, so then actually with the B4 HANA, you can use the DW data warehouse cloud, which is far better than BW4 HANA, because it can react to multiple input systems. It can accept the data and react accordingly based on the requirement. So here actually these are the raw material incoming from the vendor. You are receiving the material through a say air freight or a sea cargo, whatever it may be. So all this can be monitored in the SAP, which is interacted or integrated with the centralized cockpit using B4 HANA or DWC warehouse. So here actually logistic cockpit based on SAC BTP architecture, which is having either SAP oriented SAP implemented plant or non-SAP managed plant. That is things not matter actually. The cloud with the BTP with the S4 HANA on a cloud environment can interact with both SAP and non-SAP system. For that only I have mentioned here. Here I show that the incoming raw material sent by the vendor to the plant, so it is given to the process, I mean again given to the manufacturing, then actually once complete the finished goods given to the say quality inspection, then taken to the transportation till the end customer delivery, right? So this comprises of truck transportation were fitted with the GIS GPS inside that. So the GIS can predict the geography of the particular location. It can it can change the route whichever possible, and GPS will help you from at what point or which location the current truck is there. So GIS GPS sensors will be provided in the truck system. Is an advanced logistic track and trace system inbuilt with the automobiles, and the driver can monitor all these things. He can take a clear route, correct route, without getting disturbed during the transportation, and reaching the end customer plant in a correct time as determined as per the discussion between the parent manufacturing company to the end customer who is in some other location. So the transportation is very important. It is having the facility of GIS and GPS, even between different say main manufacturing unit to the primary warehouse or secondary warehouse. It is the same policy applies. They have GIS GPS sensors available. So all this stock will be sent to the end customer. So once the customer receives that, he will send the feedback. So I have received the material again in a correct time. So this feedback will be again given to the BTP cockpit. Again that the actual and the already received input from the from the delivery, right? That can be that can be compared, monitored and analyzed, and then taken predictive diagnostic to apply correct route, correct transportation mode, correct path to reach maximum customers in a shortest path of route, right? That is called PERT, ACM PERT, right? So all these things actually will happen. So in this case of logistic cockpit, so logistic cockpit will act as a bridge between the SAP and the user community and not for non SAP systems with the field triggering activities such as transportation, issuing, put away, all these things which is taking place at the primary warehouse or secondary warehouse or the end customer warehouse or whatever it may be. Okay, and we have SAP RAM. SAP has introduced SAP RAM, which is used for, say, for example, if a user is a non-technical guy not having any coding functionality, he can monitor the end-to-end process, can control that and track and trace that through the by interacting with the this RAM can interact with the total BTP platform or the box, so that they can get an online trending of data. So it will avoid the delays, it will improve the lead times, on the spot booking of deliveries. So and finally actually all the lead times or KPIs can be optimized, and so the manufacturing company will get a good name from the end customer. So these are the advantages. Okay, this is just a schematic diagram. So next thing actually in this slide we are discussing about high level requirement for the logistic cockpit. So what are they? So as already told, creating a design or a model to manage or control logistic data end to end. So I already told, starting from raw material procurement till the end customer delivery. Okay, and then monitor the logistic events. So each actions, procurement, manufacturing, and then say warehousing, production, quality management, transportation, shipping, loading, all this can be all the events in the complete end-to-end supply chain can be monitored and analyze and forecast the events. So it can get an output from the actual events and thereby applying that feedback to the actual events taking place at the currently. So analyze and forecast the events. So it can determine, okay, this much thing will happen here, and these are the analyzed thing where we need to take it forward. And then based on the analysis and the forecasting of events, we can plan the sequence of steps and process. So which activity to be done, so which action to be taken to get a error free process. All these things can be planned and it is properly structured in a sequence, okay, to complete the entire process and predict and act accordingly to avoid mishappenings. Say in case of something actually the stock out, stock is not available and some deficit will happen, those things can be optimized in the stock out issue. And execute and improve lead times, that is sourcing, warehousing, manufacturing, quality control, transportation, shipment, picking, packing, everything can be properly executed in time and get improved lead times and get goodwill and good deal, win-to-win situation with the customer and get a on the spot booking of tenders, so improves finally the business. These are the high level requirement for the logistic cockpit. The main requirement is to optimize the lead times, reduce the processing time, improve the action of each and every event, right, minute event, which can be tracked and traced for the end-to-end logistic optimization, and which will get a good name from the end customer. So these are the very important thing for designing a logistic cockpit using BTP with in addition to Subanalytics Cloud SAC, right? So this is very important. And next we are moving to the say how the SAP or SAC and BTP, right, integration with SAP S4HANA, EWM, TM, EM and ECC, WM, MM, LEDR, SD, all these things, right? So all this manufacturing and then quality assurance, warehouse operations, inventory warehouse, and then customer services can be well optimized in each. Each step will give you finally the customer satisfaction service, right? So that's what I placed this customer service in middle of this distribution, packaging, shipping, account, and then inventory, warehouse, quality assurance, and then manufacturing. So all these things are controlled by the mean, anyhow, the customer service will be the front end for a customer, right? They can place a defect or place an order, everything through the customer service model in SD, right? So thereby actually they are monitoring all this manufacturing, quality assurance, warehouse, inventory. They can able to track all the operations by the internal call or internal SAP inquiries there. From there actually they will update the final customer, right, about the actual distribution and everything, right? So activities, events in P2P, O2C, manufacturing, quality management, warehouse management, or extended warehouse management, LE or TM taken place at SAP ECC or S4HANA system can be properly sequenced, properly scheduled, sequentialized, and then executed, and output can be planned and executed at the with the proper analytical and predictive logistics. And integrating SAP S4HANA, ECC, and SAP Enterprise Event Management, and then interfacing with SAP BTP Logistic Cockpit will yield more optimized results. Okay, so this shows the SAP BTP functionality components already described. So this is so-called best-in-breed system, which is nothing but our SAP system. Over that we have a EBC platform, Enterprise Buyer Capability Platform. So this will act as a cover, and will act as a front-end user interface with the end customer or end-to-end business. So it will control the shortest path, effective customer reaching, and then mode of transport. The scheduling the deliveries, scheduling the release of quality, scheduling the material issue to production, receiving a material from the vendor on a raw material, and issuing the finished goods through the trucks between the different locations and reaching the final end user for their requirement. So everything can be tracked through the front end, so-called enterprise buyer capability platform based out design based out of the business technology platform in a cooperation with the Subaltics Cloud SAC. Okay. And next we are seeing SAP Subaltics Cloud and BTP integration with SAP S4HANA with related EWM, TM, EM embedded modules. Then ECC with WM, LETRA, SD, PP, QM, PM, all these things with event management integration with workflows will give you a complete details on end-to-end. So when the purchase order to be created, followed by the sending the PO to the end customer, to the vendor. Vendor will receive that and acknowledge the purchase order. He will then prepare for the deliveries. He will send the deliveries, and then actually the with the delivery challan, and then the order management, the the team which our team or organization who create the PO will receive the delivery. They will send a acknowledgement that actually the material has been received in the premise, so that actually the vendor can send a vendor incoming invoice, customer invoice. So the buyer can receive the vendor invoice. They can process the vendor invoice by comparing with the PO, and then actually the delivery with the delivery, GR delivery document, and invoice verification, all these things. Once the invoice is posted, they can do automatic payment in FIR, manual payment, right? So these are the FB0, FB03, or whatever it may be, actually F-03, all these things matter, right? So this I showed here actually it can be now actually the end customer in Asia can order the American manufacturer. The American manufacturer can receive that PO, and they can send that. So we have received the PO and send the acknowledgement to the end customer in Asia sitting in India. And again actually they will send the delivery to the end customer. They will receive the end customer in Asia or India will receive the delivery with the delivery challan. They can do goods issue posting, and then actually they will request the American supplier to send a customer invoice. Once receiving that, actually they can send a customer invoice to India. Customer in India can receive that as a vendor incoming invoice, and then they can process that using three-way match, and they can finally settle the end customer. So in between that we have procurement of material, put away after quality inspection has been test has been passed, and then doing put away, issuing the raw material to the production, converting the raw material to finished goods in production, and then we are doing quality release for the production for the finished goods. If that is okay, then it is issued to the unrestricted stock in the warehouse. Based on the customer orders, the warehouse will prepare picking, packing, all the deliveries and shipment, everything. So the shipment is processed, transportation started. It will send the stock to the primary distribution centers or secondary distribution centers, or from there actually they can reach the end customer locations to distribute the stock. So end supply chain management can be tracked and efficiently reported to the supplier, or as a main company who is manufacturing that, for doing the business with the customers, right? So everything can be achieved, can be tracked through the BTP in a centralized cockpit. Okay, so enterprise management actually it's an inbuilt in case of our recent S4 HANA. So that is not a big problem, right? So that is important. And what are the advantage in case of transport processing by the specialized service providers, right? The advantage that results from this can be illustrated with the two simplified extraordinary scenarios as they take place with a supply shipper in the inbound areas. The continuous data exchange already begins when the transport inquiry is created in the SAP TM. As a result, the suitable service provider, including freight conditions, can be generated automatically. Right here, SAP or TM collaboration tools can be used, which also access special offer, that is SAP BTP, SAC BTP Logistic portal, so that an individual consistent freight allocation can be triggered. So all the freights can be properly scheduled, and consistent availability of material with the freight is triggered. Furthermore, order relevant data can be transferred to SAP EWM via SAP TM, so that deliveries can be specially marked in the warehouse if required. With the help of track and trace in SAC Subaltics Cloud and Business Technology Platform, along with SAP Transportation Management and EWM, it is also possible to obtain information in real time about the possible delays in order processing and damage to goods. Okay, and in order to be able to counteract in the real-time delays, to optimize the real-time efficient optimize lead times with deliveries. Also, SAP Transportation Management, Subaltics Cloud, and Business Technology Platform in integration improves the communication between you as a shipper and your suppliers, logistic service providers, that is 3PL or 4PL, and customers, right? End customers. Simply provide your, I can say, partners with a portal. I can say with the partners with the portal and apps, so we can provide the facility to your end customer to track and trace the goods from Merck warehouse. I can say the main warehouse, that is primary and secondary distribution centers, that can be used to display relevant data and also record yourself for the client. Say Merck is a kind of say, I can say, a pharma life science healthcare companies. Actually, they need exactly this kind of BTP technology implementation in their sites. And actually many companies like AstraZeneca, then Cipla and Ranbaxy and Pfizer, and then many companies, right, actually, or they are expecting this design for, BTP with the SAC for the end-to-end tracking of logistics, starting from custom vendor, vendor procurement of raw material till the end customer supply, right? So this is required. So in our case, I am giving Merck as an example. Okay, so now actually among other things, you have the possibility to communicate with the drivers in the network, right? So which are all the drivers in the path of transport, right? Those the drivers can be considered as a network, so which can be already mapped, right? In TM best practice it is already there. So I am not a TM consultant, but actually this option is available in the TM best practice app. Okay, The advantages is that upcoming tours and shift plans are transmitted in real time, and ship and yard management is supported in the selection of suitable vehicle or other means of transport. I can say the end-to-end logistics. So track and trace of data from SAP TM and SAP EWM documents, right? Then the order intake, the time at which the order picking is triggered, as well as the end of packing, right? End-to-end packing process, the successful loading. So, and then the departure of truck from the plant premise and arrival at the consignee. That is I can say the end customer. And end customer is nothing but a consignee, and consignor is the one who is supplying the material, right? So that is the difference. Actually, these are the business terms you need to come across in a day-to-day life, right? So these are the advantages. Actually, I think I mean this is the logistic part, as everybody experted or yeah, new consultants can understood the concept, right? So normally the vendor will supply the stock to the customer, right? Or based on the requirements or order placement. So I don't want to go very deep. I mean, I don't want to deep dive into that. Just I'm giving the highlighted or a high level overview of logistics. So now we are moving to the next slide. So here transportation management and telematics with SAC BTP, right? Telemetry using global, I mean geographical position system and geographical information system. Okay, I already described all these things. So the GIS and GPS can be fitted to the truck or attached to the truck, so that the real-time data can be sent and received between the say BTP cockpit and the local GPS and GIS, which can be received BTP through a Internet of Things, and all this sequence, which signal to be sent first, which signal to be sent second, can be programmed using the artificial intelligent RPA in addition to the AI technologies. Okay, and transportation systems management systems such as SAP TM or the business oriented software solutions for determining freight requirements, cost and revenue. It manages, operates, controls and optimizes entire transport process, ensures efficiency in goods movement and interacts with the warehouse and higher level ERP systems. Okay, the range of services of SAP Subaltex Cloud, with in addition to the in coordination with the Business Technology Platform integrated with SAP TM, can be extended used by the can be externally used by the integrated telematics. Telematics integrated with SAC and BTP with SAP TM transportation management describes the use of requirement equipments for the determination of positions and transport data via internet. It is used for data gathering, that is telemetry. The objectives are optimize of driving behavior, reading the tachograph, that mean working driving and rested times where the driver is taking rest in between the travel, so how much speed is moving, driving efficiency, working efficiency, all these can be connected to the real-time cockpit. So all this connection of onboard units, that is OBUs, and GPS data, that is location and geofencing, right? So navigation, monitoring of emissions, CO2 and emissions, right? O2, nitrous oxide, all these things, right? Which we need to take care that these emissions will not affect the chemical composition of drug which are transported, and consumption values, connection of further sensors, trailer boxes, black box, temperature. Black box is, I know actually those who are no in air freight and sea freight, we have the black box to record all the events, so that if any mishaps happen, they can analyze, or the police can track, record, I mean, can monitor all the events happened during the last final stage of before the accident, right? They can able to take a corrective action, or which area that a particular incident happened. Everything, I mean, a sequence of timestamps, the events can be tracked using the black box to avoid the future mistakes from the realized I mean incidents. So temperature sensors, CO2, the I mean carbon dioxide, hazardous material tracking, environment tracking, vehicle data, that is CAN bus, all this can be I mean supported and track and traced using BTP in addition to the SAC, IoT, artificial intelligent technologies, AI technologies, artificial intelligent robotic process automation. All these things can be achieved here. And suppose an efficient fleet management system means vehicle management system as well as communication with the driver, right? The main manufacturing or a warehouse actually I mean implemented with BTP with SAC can do communication and tracking, tracing with the driver and logistics, right? Example, order transmission or for the status feedback. So thus example, the driver premium efficient driving, how speed he can do, what are the rest times he is taking in between which locations, how many hours he has taken, what is the working hours, driving hours, everything are possibly tracked. And then container tracking and active GPS station is tracked properly for the efficient determination of the stocks in between the travel from source to destination. Okay, these are the advantages of BTP and SAC over the transportation management deployed with the telematics, right. These are the advantages. And next we have a consistent track and trace, right, of stocks or truck movements. Okay, the traceability of stocks or truck movements is a matter of course for today's consumers. So how much possible to track the exact stock movement can be done through the available GPS and GIS sensors. Due to the progressing digitalization IoT, the associated potentials are being used increasingly in the area of transport and intralogistics, especially as a especially as a track and trace offers quite interesting cost savings, while conventional data exchange using EDA and DFU will not give an exact data, right? Just you can get an update from the third party system or external system, but you cannot get the actual picture. What is the status? You cannot get a predictive logistics, you cannot get an analytical logistic real time environment, right? So EDA and DFU has long become a standard. So it cannot give you it can give only a conventional data. It cannot give you an exact track and trace cost saving measures which will not give. Okay, the use of SAP extended warehouse management, SAP EWM and transportation management, right, with SAC built on BTP opens up large number of extended application options. Okay, whenever via the information and the communication portals via app from the cloud or via GPS geographical positioning system, the flood of data is growing nowadays. In order to be able to generate the added value from the existing data, there must be presented in the, I mean this data should be presented in a clear, a very sorted out manner or a structured manner, right? So that you the end customer or or the person who is getting the benefit, who is a beneficiary, can get all the details in a real time data. Only then it is possible to integrate analyze functions to implement a solid monitoring and to be able to use gained track and trace information for the reliable time discussions, or also a predictive optimization, right, can be achieved. This predictive diagnostic or predictive optimization I already explained in the third page of the of this slide. This can be achieved in SAC, that is Sub-Analytics Cloud, on BTP, Business Technology Platform technology, which is newly developed by the SAP. On when the cloud technologies has emerged using SAP S4 and also coming into picture, so we have the now optimized action on consistent track and trace of stock and truck movements. This means the inbound and outbound deliveries, that all procedures and work steps can be completely monitored, recorded, analyzed, planned, predicted, and tracked. These are the important sequence of operations to be done on a data. Finally, tracked. This begins with the sensor technology of storage and transport facilities and extend to the proof of delivery POD sent by the end customer. Okay, by the customer, right? By the customer, track and trace using SAP TM and SAP EWM enables you to profitably use the standardized process data for the benefit of your customer and your company. So these are the consistent advantages over the track and trace of materials and trucks movements from the source to destination. So next thing here, I am showing the logistic cockpit capability to track and trace from end-to-end purchasing to delivery using BTP and SAC. Just I am giving the diagram, right? Inbound components sent, coming from truck, so it can be sent to the warehouse and then issued to the production, and then once the finished goods is received, it will be placed in the production warehouse. From there the production supply operates. It is placed to the raw materials can be given to the production, and once the converted to the finished good, it will be placed in the production warehouse. So from here actually you can give send to the finished goods warehouse, and then actually based on the customer orders you can do start creating the orders, and then with reference to the orders you are creating the sale, the outbound delivery. And then once you create an outbound delivery, it is an initial request, so thereby picking, packing, loading, and confirming of orders. And so PGA happens, then followed by the shipment followed by the shipment document creation, and then actually transportation model is coming to picture. It will transport between the different locations and reach a final thing. And all this, the efficient route, best route to cover best route to cover maximum customers in a short span of time, or shortest path, right? That can be decided in the route determination model in the SD, and also followed and tracked by the transportation management system. So after many intermittent staging, it will be sent to the final shipping to the customer. So once the shipping happens, once I can say picking, packing, loading, PG, everything happen, it will be placed to the staging. Or in some companies, once a PG happens, it will be moving from staging to the shipping yard, and there actually their shipment started. So it will be sent to the end customer. This is the overview of logistic process. Okay, I explained through the diagram. I hope it is very useful. So here events are propagated between the subsequent objects in order to achieve end-to-end visibility. What are the visibilities we can do? In ERP or S4 HANA, you are creating the sales order followed by the delivery followed by the shipment. In between the sales order creation and delivery, we have in actual logistic cockpit track and trace, we need to have a sales order creation, sales order response, and then delivery creation, delivery time processing, and then delivery picking, packing, loading, and then doing outbound delivery PGA, and then shipment point, shipping transportation. So all this can be track and trace using the tracking document, using the shipment document, delivery document, and order document. So which can be transported here and there. Each output of the first phase can be given to the input of the second next continuous consequent phases. It will goes on till the final invoicing happens, right? So that is the process shipment, and then supplying, right? Supplying tracking document, everything is tracked, which is given as an input, right? So these are the events are propagated between subsequent objects or actions in order to achieve end-to-end visibility. So here you can give the picking, packing, and then loading point, loading start, loading end, and then actually shipment start, and so supplies can track everything. So shipment tracking, delivery tracking, delivery from the cockpit from tracking. So whether it is a sea or the mode of transport, right? Road or rail or air freight can be determined. So the shortest path with the efficient maximum customer reach can be possible in a minimum time can be determined from the, I already told, through the routing module. Route determination happens at the order management, right? So these are in SD. So these are the different phases we are going to see in SAP BTP. Okay, these are well structured. All the output of the first stage here, output of the first stage will be issued as input. Again, this output of this stage will be issued to the consequently given to the next stage. Thereby it goes on. So the feedback again it is given to here, and then the actual and the exact prehistoric data can be compared and given the best results. So the tracking documents are well tracked, and have a end-to-end track and trace of overall I can say overall logistic activity, right? So that is what, and even here actually you can see at what point of time start and end activity, shipment start end, or picking start and picking end, packing start packing end, whatever, and loading start loading end. All these things are order creation or delivery creation, processing, delivery processing time, shipment processing time, transportation processing time. Everything can be tracked here. Okay, that is the beauty of logistic cockpit using BTP SAC development technologies. Next, we are moving to the next slide. So here you can see end-to-end logistic transportation, monitoring, tracking, and prediction using logistic cockpit. So you can starting from sales order creation. Next, it is going to the freight planning. So contracting, I mean, there is a data between the contract and freight planning happens, and resource utilization, how much resource can be used to optimally optimize the pick, pack, loading, and all these transportation related activities, and what is the utilization against each resources deployed during these phases, and freight execution. After freight planning, we need to follow freight execution, and here also the dock appointment will integrate with the freight execution. So it is a series of steps: order creation, freight planning, and then resource utilization, how much resource can be utilized during the flight planning. And once a resource can be determined, I mean resource utilization can be obtained for cost estimation, it will be taken to the freight execution. So dock appointment happens, then it is taken to the freight monitoring. So execution, actual execution starts here. So to and fro data can be tracked here and there between these two: execution, dock appointment, contracting with the actual BTP. Okay, after freight monitoring, it is taken to freight charges, cost incurred for the freight movements, right, in carrying the material, and freight settlement through the shipment papers, and finally freight cost accounting will be hitted in the finance department. So it is a integration of OTC with FI, right? So accounts receivable AR thing. So here events tracking in logistic cockpit. So what are the receivable and deliverable thing as there, right? Actually, so what are the stages during receiving? What are the actions happening, right? Choose the creamy layer of that. So all these things can be, so manufacturing. So choose a nuts. So all these things actually each and every CNBAL, bad, all these things don't get confused. Actually, this is a sequence of operation or event taking place in a manufacturing unit or any process industry. Just I am giving the sequence of operation taking place: user execution, release, particular delivery, everything, right? So just an events triggering, not please do not go deep dive into that. Just I am giving for the understanding purpose, starting from order management till the freight cost happens. I am just giving an example here. I mean, it is not an actual thing, it differs from client to client. We need to bear this in mind. Okay, and next we are going to the next slide. So here actually end-to-end logistics using transportation monitoring, tracking, prediction using logistic cockpit, BTP SAC. So what are all the activities you are planning here? Say sales order creation, purchase order creation, stock transport order, returns from vendor or customer, inbound, outbound delivery, shipments, scheduling agreements. So everything can be followed by the, I mean, can be sequenced using freight planning, resource utilization, freight execution, and then transportation documents, which are the shipment paper, then followed by the freight monitoring of the output results, freight changes if any, freight settlement, and then freight cost accounting, right? So this will give the conventional loading or packing, and material valuation, and then sales order update. All these things can be tracked. So this is the upper portion will show the TM activity, and here the that is supplier side, and the bottom portion I have divided. These are the carrier side. Okay, so this is supplier side. All this happens at the supplier side, and this happens at the carrier side. So the supply side integration and management of all the transportation demand, contract, dock appointment, milestone reporting. So each phases can be subdivided into different phases: freight planning, freight evaluation, freight monitoring, freight charges, freight settlement, freight cost settlement. These are divided into different parts or stages. So each can be settled in each different phases. That is called a milestone reporting, dividing the actual cost into different phases or events. Based on that, you are paying the or doing settlement, right? That is called a milestone reporting or milestone billing. Finally, the invoice submission happen. So here in carrier side, you have contracting with dealing with the tendering, quotation processing, and subcontracting. And appointment relates to dock appointment scheduling, and execution deals with milestone reporting and document exchange. And again, actually, the invoice submission integrated with the settlement will give self billing, carrier invoicing, and dispute management. All this carries under the portion of carrier side. Okay, these are the differentiation I had tried to give. I hope it is well understood how the supplier side and carrier side are integrated in the transportation management, integrated with the cost estimate, supplier or freight cost accounting. So here actually we have SAP will give the percentage of carbon footprinting, right, using CO2 by Logistic Cockpit, by having the analytical and predictive modules inbuilt with that, right, for the cloud analytics. So example of cloud analytics, right? Cloud analytics which will give how much percentage of CO2 or NO or nitrous oxide available, oxygen available while doing transport, right? So this will give the clear picture CO2 from the purchase raw material, and here it shows second purchase CO2 from the energy activities during conversion of or manufacturing, and how much percentage of direct CO2 emissions happen from the manufacturing plant, and from warehouse against orders you are supplying the material. So how much percentage of carbon dioxide emission from the outbound transport using the truck, and again finally once reach the end customer place, actually how much CO2 was I mean actually consumed while doing transport to the end customer or a primary warehouse or a secondary warehouse. So again any transport between the manufacturing unit to the manufacturing warehouse to the primary warehouse or a secondary warehouse or end customer will be the same. We need the S4HANA will have a inbuilt analytics as well as SAC embedded over it. In addition to the BTP, they can able to track and trace all the CO2 emissions can be tracked from the I can say emission monitors, emission sensors, which can be integrated with the truck, same like GPS or GIS, which can give the real-time environment of different gases or CO2, CO, NO, I mean even sometimes actually sulfur emissions, everything, right? So all this can be the vehicle actual exhaust, the manufacturing exhaust, and say for example, once you are keeping the product in your warehouse, how much percentage of emissions happen, or how much surrounding temperature or I mean the exact chemicals available. So everything can be taken through the carbon footprint technology deployed with the S4 HANA BTP with Subantics Cloud. This will I will show the percentage. You can take a circular chart and determining how much percentage of sulfur, CO2, CO, or NO, or whatever it may be. The gases available in the atmosphere due to the production. And here the trending of data using graphical analysis, monitoring of CO2 using Logistic Cockpit. So here you can see here actually 159.6 K can be done, and here actually we are having 149 K for the purchase of some materials, and all this actually each will have how much percentage, right? You can give a circular chart of thing, and each portion of this coloring will show percentage of emissions or exact pictures taken place in actual process, which can be track and trace in S4 HANA embedded with a or deployed in a SAP BTP SAC layout. Okay, this will give the actual picture, so business can track and trace all these things. This is how the business can track and trace exact data and get the real proportion of data in the field space. Okay, So they can able to control, track and trace, and predict and plan and schedule all the activities from the gap they are receiving through the input from the IoT, and scheduling everything can be through the automation, then robotic process automation. Okay. And here these are the end-to-end logistic of tracking and tracing by SAP BTP and deployed in addition with SAC. So what are the observations? Okay, so this will BTP SAC combination built with I mean this EPC enterprise buyer capability portal, logistic portal built with BTP will give you the improved transparency of transportation or material movement or stock movement, and with the end customer can trust that manufacturer and sustainably by connecting your end-to-end supply chain 24/7, and then establish a repository of sustainable data as a foundation for continuous improvement, right? So can you improve your process continuously without disturbing the existing process, and help consumers making informed decisions, right? So the end customer can be informed, predetermined by providing them all the relevant real-time data so to monitor, and then support shippers in their collaboration with third-party logistic provider to have a clear picture of how much time they can do work or transport, how much time they can able to take rest during in the intermittent during the operations, how much time they need to keep an eye on the track, how do the delivery, how much time they can take some additional time to cover that end customer delivery. Everything can be given to the shippers so they can efficiently monitor all the things. Once the say the vendor is given, a vendor or the main company supplying, right, supplier is given all the data, the transporter will efficiently act accordingly and bring the best results and give a goodwill between this end customer and the manufacturing unit, right? So like pharma companies or life science companies, and oversee the complete freight order life cycle and manage appointment on the spot booking efficiently, and leverage real-time connectivity and visibility over the process end to end, right, to track and trace the and track and trace and execute the end to end activity starting from procurement till the end customer delivery. So these are the capabilities which can be which we can perform using SAP S/4HANA with SAP BTP and SAP Analytics Cloud, right? Using the logistic cockpit design. Next, what are the remaining merits? So allows business user to get a real-time transparency of business process, and then query, questioning any tracked process and display its retrieved data. Whatever data you can receive, you can retrieve the data end to end, and provide rule-based triggering when certain predefined conditions occur, such as delays or mishaps. They can give the rule-based triggering and then trigger or give you impact to increase the action or optimize the operation without by avoiding the delays. Quicken the process. You can quicken the process. Make optimized transportation routes to determine proper routes, shortest path, maximum coverage of customers in short span of time, right? While considering the available capacity, right? And get full of visibility of routes and capacities through map use and Gantt charts. Manually adjust and tweak the automated and optimized transportation plans. Okay, these are the benefits. And here you can see the truck driver is operating the GIS or GPS sensors or gas, I can say environmental monitoring sensors to track how much percentage of CO2 is involved, and then how much percentage is there any rain, is there any, what is the exact temperature in a particular path, what are the from where we are moving to which point, what is the how good the particular route is there, is there any physical disturbance, political disturbance, so that we need to take an alternative path or mode, change the mode of transport. Everything can be determined using this device. So all these things can be inbuilt in a truck, so the driver can be benefited morely. He can do immediate sending of data and updates of feedback to the center or a pharma company, so they can take alternative decisions if and when required. Okay, if and required. And this here actually you can show the GPS positions, right? So using the positioning system, you can track the exact better route, how much customer has to be covered in a short span of time, best route, right? The pet and all these things. So carrier route tracking using GPS, determine best route using GIS connected to BTP Logistic Portable, enabled by the SAP Cloud Analytics, will give the best route of result. So in TM you have the option to track and trace the number of customers, maximum customers covered in the shortest span of time with the shortest route. Okay, this can be this is called optimized route from say this point to this point, and again coming here. So instead of going to alternative point, say for example, if they want to go like that, say if they want to reach, say instead of going here, you can these guys are following this path and then reaching the end customer, and then again coming back to the original portion. So these are the advantages, right? So I'm using the laser pointer, and okay, now it shows a map, I mean Google Maps kind of thing. So we can the SAP TM will have an inbuilt functionality over that. So SAP BTP is using that functionality, so no problem in that. Okay, next screen. So what are the information model required for the logistic cockpit design using BTP with SAC? So order management, say logistic information model for logistics cockpit given as an input to SAC, that is Analytics Cloud data access with respect to model and functionality. So what are they? Order management, we have customer and customer order data, and ERP in the sense inventory, that is finished goods in transit, and then production plans, material master, and then batch master, shipping orders, contract data, invoices, and quality release will come batch data, quality control release schedule, and supply chain planning includes supply plans, demand forecast, and then external manufacturing includes supply plans, inventory containing finished goods, in transit materials, shipping notifications, and then again returns or recall process, right? Any manufacturing industry will have returns and recall. Even with actually a distributor or wholesaler or retail, we have the returns and recall, right? So that comprises of returns of material, product recalls, and then replacement orders, credit debit notes, and then cold chain, which includes a temperature exertions, temperature logs, fleet management systems. Everything comprises of cold chain in general. And we have the warehouse management system will have the data comprising of inventory, that is the stock keeping units, DC distribution centers, and then picking, packing list, shipping plans, and then docking schedules and shipping events, and then transport management systems includes carriers, freight forwarders, freight cost, freight orders, then lead times, that is lanes, lead times with I can say mode, and load per module, shipping legs and routes, shipment plans, shipment events, and then on the spot or spot rates, on the spot booking, and emission data. All this comprises of TMS, that is emission data means CO2, CO and NO, all sulfur kind of thing, all these things, right? Sulfur dioxide, all these things, sulfur monoxide, everything. So track and trace, which will includes packaging hierarchy, serialization data, and regulatory data, which comprises of a particular company's drug or media pharma rules and policies, right? Which comprises of all this. So these comprise of all these things. Logistic information model comprises of order management, then supply chain, external manufacturing, warehouse management, transportation management system, track and trace logistics, cold chain logistics, returns and recall logistics, quality release, quality control release, and ERP, enterprise resource planning, which is given as an input to the BTP SAC platform. So efficiently track and tracing of data starting from procurement to end customer deliveries can be achieved by optimizing the supply chain management KPIs and encourage on the spot booking of transports. Okay. So next comes what is a we have many times I told what SAP BTP, SAP BTP. So what is SAP BTP, right? Is so called business technology platform. So yeah, BTP is a platform for intelligent enterprise. So customers can achieve agility, business values, whatever they planning and expected, and can achieve the continuous innovations and simplifications through the integration of different systems and different data, both SAP and non-SAP, and different field device data, GIS, GPS, and then emission monitoring systems by facilitating or getting assistance from SAP S4 HANA embedded as well as Subnautica Cloud, SAC, and addition with BTP architecture over the cloud environment of SAP S4 HANA. So this BTP was come into picture or come into vision after SAP S4 HANA cloud premise, right? So and also it will support the on-premise server network. That is also possible. Okay, so it is an hybrid model. If SAP BTP is an hybrid model. Whether if anyone is asking SAP BTP is a standalone, I mean on-premise or cloud or hybrid, the answer will be hybrid because it supports on-premise existing network, that is old technology client server networks, as well as S4 HANA cloud enterprise, everything, and also it supports all the kind of user interfaces, say Fury, I mean I can say graphical GUI interfaces, everything can support. It's a Symbian, whatever it may be. So it is an universal interface or universal technology which is having a inbuilt analytics as well as predictive technology. Okay, and BTP is extensibility of all I mean integrate all the data to value and extensibility of all SAP products and third-party applications. I already told in order management for checking the order related status and everything, right? As a third-party application and data assets, right? Optimize process that cross lines of business and achieve competitive differentiations with SAP BTP embedded in SAP applications. Run SAP BTP in any hyperscaler cloud environment for flexibility and customer choices. Okay, achieve your goals with the flexibility to build, manage, and deploy your applications and connect data and business process on one integration platform, so-called business technology platform, in collaboration with Subnautica Cloud. Okay. So this is the business technology firm is nothing but a intelligent enterprise which facilitates the customers. Where they will give the business values and continuous innovation through the integration of data till the value to the predictive logistic, right? And it will extensively optimize the all the SAP and non-SAP third-party applications of data and assets. Okay, and optimize the process through different cross-line business and achieve competitive environment in business by differentiation. Even if you want to differentiate, you can do, and it will collaborate or compose everything with SAP BTP embedded in SAP application, right? So it's an hyperscaler cloud environment flexible for the customer choice. Okay, and customer can achieve their goals whatever they need, they are planning using BTP and SAC on a cloud environment. So these are the component actually where SAP BTP comprises of database and data management, analytics, and application development and integration, and then intelligent technologies, right? So we have operation runtime, so open application interfaces, open environment, and functional services, and then cloud on-premise hybrid edge, whatever I told, and then any data store connectivity can be integrated well in SAP BTP. So in case of database and data management, what are the components? So we have SAP HANA, SAP HANA Cloud, SAP Data Intelligence, and SAP Master Data Governance (MDG), and SAP Adaptive Server Enterprise. And when we are coming to analytics part, we have different components such as SAP Analytics Cloud (SAC), SAP Data Warehouse Cloud, SAP Business Objects BI, and SAP Business Planning and Consolidation, and SAP B4 HANA, right? So this B4 HANA and data warehouse or actually can replace one another, or sometimes actually SAP is suggesting B4 HANA in addition to DWC. So it depends on the customer actually. Whenever which component you need to use, you are already using B4 HANA, then it is good to use connecting the on-premise with the BTP cloud. Or if you want to go to entire cloud architecture, you can go for SAP data warehouse cloud. Okay, these are the options. Actually, I will definitely describe each and every component and why we need SAP B4 HANA and SAP DWC in combination. Why can't we can we use it separately? The answer will be yes. I will tell the reason in detail in my next part of BTP thing. And then we have application and development integration. In that we have SAP integration suite, SAP extension suite, and then we have SAP process orchestration, nothing but SAP POPA. So this comprises of application, development, and integration. Finally, we have intelligent technologies, which is connected with the field devices and getting the feedback from the field devices, giving orders to the or command to the external field devices from BTP cockpit. So what are they? SAP Intelligent Robotic Process Robotic Process Automation, simply called SAP AI RPA, SAP Conversational Artificial Intelligence, SAP Internet of Things IoT, SAP AI Business Services, and SAP RAM. I already told this is a application or a tool which a non-coding user or not the user which is not having knowledge, they are not having access on the coding part, having the knowledge on coding part, so they can easily track and trace interact with the BTP cockpit to track and trace end-to-end logistic action, and whenever any feedback is required, they can able to provide the feedback. So efficiently they can control without a coding knowledge or a software knowledge, right? That is important. It's a user-friendly interface tool. So next we are moving to the IT landscape, that the different SAP systems, right, can interact with the Subanalytics cloud through either through DWC data warehouse cloud, or if they already have B4 HANA in their S4 HANA implementation, they can use that. So non-SAP in the sense JDA, order management tools for order tracking, then laboratory information management system for QM, and SAP in the sense ECC with LETRA and WM warehouse management, MM, PPSD, QM, all these things, and then SAP event management and SAP master data governance, and SAP S4 HANA with SAP TM integrated TM or embedded TM or standalone TM, and SAP EWM, SAP enterprise, event management, and SAP MDG. So these different non-SAP and SAP system are integrated with SAC further to undergo analytical and predictive logistic function to track and trace efficiently the logistic operations starting from vendor procurement till the end customer delivery on the BTP part. SAC is one part of analytical tool in BTP. So what are the necessary business process required is for SD order and delivery management and supply chain planning for planning module, and manufacturing we have PP and everything, supply chain planning APO, and warehouse management WM or EWM. TM management, it comprises of LETRA or SAP TM, and track and trace cold chains will is a separate thing for a environment health and safety model, and then quality control release QM model. So which all this can be integrated to a BTP or ACC to improve improve or optimize the supply chain KPS. So source lead time for procurement, warehouse pick pack lead time for WM, and manufacturing lead time for manufacturing or PP, PB or production planning or production execution, and quality lead time related to QM management, QM model, and outbound lead time for again actual delivery management, and transportation lead time for the TM or LETRA. So I have given each KPI is related to each model in a ERP or CM model. So these inputs are can be connected. All this process can be connected through the one data form, either it is a DWDC if it is a new implementation, or if you're already having S4 HANA in place with the S4 HANA ERP, then actually you can use one data I mean before HANA, which can be integrated with the SAC. SAC having four different functions. It can receive the data from the connected systems through before HANA or DWC. It will monitor and then it will analyze the data and do predictive logistics from the analyzed data, and then finally execute the predicted logistics. So thereby optimize the lead times on the spot booking. And SAP BTP is again, actually I'm telling, is a I mean SAC will be the part of SAP BTP, and all this actually AI, IoT and RPAs and DWC and before HANA and SAC and RAM, all these things. I mean MDG, internal MDG, MDI, all these things. Lot of things are there. So all these four different components, I mean four important subdivisions. Each subdivision have different components. All this forms a SAP BTP. SAP SC is not only the BTP. SAP SAC is a part of analytical tool in BTP. Okay, so this I have given here. So with this, actually, I am stopping our first, the first part of logistic enterprise buyer capability logistic cockpit design using SAP BTP in conjunction with Subanalytics Cloud. And this is a part one of the video. And in next part of the video, SAP BTP with SAC for the enterprise buyer cockpit logistic cockpit design. Part 2 will be coming in the next video. I will definitely give the technical part of the coverage in that video. Okay, so I hope the details have given is a functional requirement, or this is suitable for the functional I can say functional consultant, say MMPP, SD, QM, PM, TM, EWM, LETRA, or the SAP WM, SAP Event Management, or whatever it may be, or a non-SAP consultant to integrate all their models with the BTP in addition to the, and part of SAC, right? SAC is a part of BTP, right? So how to bring the end-to-end logistic cockpit design using BTP? That is very important to optimize the supply chain KPIs and which will give the on the spot booking and give a goodwill to the end customer on the manufacturer or the pharma company who is doing this business. So this is suitable. SAP BTP will be more suitable for the pharma drug manufacturers, and then life sciences, healthcare, or say consumer goods or beverage industries, drug industry, fast moving consumer goods industry. This is very useful for track and trace, starting from vendor procurement of raw material till the end customer delivery of finished goods to the end customer. So I hope this video is very useful for each and everyone. Thanks for watching my video. This is GV Shivakkumar signing off. We will see in the next part of BTP video, that is pure technical related, and this part 1 video comprises of functional details of SAP BTP and SAP S4HANA, SAP SAC, and all the related ERP modules, non-SAP modules. And this is for functional consultants. Even technical consultant can undergo this. They can watch this video, but actually this is a part of functional. And in the second part of BTP video, I will share the technical part of the BTP and each component description or functionality or application over each component in the BTP cockpit. So how we are going to deploy that, how much, what are the advantages, disadvantages, no disadvantage, fairly, frankly telling, only disadvantages only, and merits and demerits, how, what is the architecture of BTP, and what is the usage of each and every component, what is an ingress and egress layer, layer and egress layer, what is a data processing layer, how S4 HANA utilizes OLTA, OLTP, cache memory for to avoid data loss, everything. So I will give the detailed technical overview in my second part of BTP video. Thanks for watching. Again, I'm saying this is GB Shivakkumar signing off. Thanks for continuous support. Please subscribe my videos, and if you are interested, you can share with your friends. Provide likes and subscribe my videos. Thanks, friends. So I already told we will see the remaining logistic cockpit portal design in BTP part 2. Thanks. Thanking you.